Welcome to another deep dive. Today we're going super dark, like really dark, with Vantablack.
Vantablack.
Have you heard of this stuff?
Yeah.
Vantablack. I mean, you hear the name and you think, okay, black, but it's much more than that.
It's way more than black. I mean, think of like the blackest black you can possibly imagine and then times that by like 1,000.
Oh, wow.
That's kind of what we're dealing with here.
Okay, so it's not just black, it's like the ultimate black?
The ultimate black, it absorbs almost all light that hits it.
Like, how much are we talking?
99.965% to be exact.
99.965%.
Yeah.
So basically all the light?
Basically all the light.
That's crazy. So where does it all go? I mean, light is energy, right?
Yeah, so it all gets turned into heat, basically.
Oh, wow.
So the secret to how it does that is in its structure, it's made up of these microscopic carbon nanotubes.
Carbon nanotubes.
You know, kind of like a forest, but like a super tiny forest. And the nanotubes are arranged vertically, so they're all standing upright. And when light hits, it kind of gets trapped in between all these tubes, and it just keeps bouncing around and bouncing around, losing energy. And eventually it just all gets absorbed and turns into heat.
So instead of the light bouncing back to our eyes, which is how we normally see things,
Yeah.
it's just going into this forest of these little tubes and getting lost.
Yeah, exactly.
Wow.
So it's kind of like a black hole for light.
It's really been in my mind trying to visualize this. So we're looking at a material that's not just a different shade of black. It's almost like the absence of light itself.
Pretty much, yeah.
Okay. I'm starting to understand why this is such a big deal now. What can we actually do with something like this? I mean, besides, just staring at it and being amazed by it.
Well, there's actually a lot of cool applications for Vantablack.
Okay, like what?
Well, one of the big ones is stealth technology, making things invisible to radar and other detection systems.
Oh, yeah, that makes sense. Like if you code an airplane in this stuff, it would be pretty hard to see.
Exactly, especially at night. I mean, you wouldn't even be able to see it with night vision goggles.
Wow. So we're talking about next level camouflage here.
Next level for sure.
But it's not just for hiding things,
Yeah.
right? I've heard about Vantablack being used in space exploration.
Oh, yeah, definitely. It's a big deal in space.
How so?
Well, when you're trying to observe distant stars and galaxies, one of the biggest problems is stray light.
Stray light. What's that?
It's basically light from other sources like the sun or the earth that bounces around and interferes with your observations.
So it's like trying to see a faint star with a bunch of other lights shining in your eyes.
Exactly. It makes it really hard to get a clear picture, and that's where Vantablack comes in. It can absorb all that stray light and give you a much clearer view of what you're trying to observe.
Oh, wow. So it's like giving telescope supervision.
You could say that.
That's amazing.
Yeah, it's pretty cool.
Okay, so stealth tech, space exploration. What else? What about art? I've seen some pretty wild pictures of sculptures coated in Vantablack.
Oh, yeah. The art world has really embraced Vantablack.
It's crazy because it makes everything look so flat, like two-dimensional, even if it's a complex shape.
Yeah, it's like all the depth and texture just disappears.
Yeah, and it's so weird to look at because your brain knows that the object has dimension, but your eyes are telling you it's completely flat.
It messes with your perception for sure.
So we've got a material that's practically invisible to radar, and infrared makes telescopes more powerful and turns art into these mind-bending optical illusions. Is there anything Vantablack can't do?
Well, it's not magic.
Oh, right.
It does have its limitations.
Okay, so what's the catch?
Well, for one thing, it can be quite fragile.
Fragile.
Yeah, remember all those delicate nanotubes we were talking about?
Right.
If you touch it the wrong way, you can damage the structure, and then it won't absorb light as effectively.
So it's not like you could just slather this stuff on anything.
Not really. It needs to be handled very carefully and applied using special techniques.
I bet it's pretty expensive, too.
Yeah, you're not wrong. The production process is quite complex and involves some pretty specialized equipment.
So it sounds like Vantablack is amazing, but it's not exactly something you can pick up at the hardware store.
Not yet. Anyway.
But I'm guessing scientists are working on ways to make it more durable and less expensive, right?
Oh, yeah. Definitely the research and development is ongoing.
Okay, so what's next for Vantablack?
Yeah.
What does the future hold for this incredible material?
Well, that's a great question, and one we'll be exploring in more depth later on in this deep dive.
Excellent. I'm looking forward to it.
So before we jump ahead to all that, I think it's worth going back to, how we even got to Vantablack in the first place.
Yeah, that's a good point. It's not like this stuff just grows on trees, right?
Right. It's not something you find out in nature. It's actually a product of nanotechnology.
Nanotechnology. So those carbon nanotubes we talked about?
Exactly. Those tiny tubes. They're the key to the whole thing.
So scientists weren't actually trying to invent, like, the blackest blacka. They were working with these nanotubes for other reasons.
Yeah, at first it was all about the unique properties of carbon nanotubes. I mean, they're incredibly strong, lightweight, and they can conduct electricity like crazy.
So they were already a big deal even before Vantablack came along.
Oh, yeah. Huge potential in all sorts of fields like electronics and material science.
So how did they go from nanotubes to this ultra black material?
Well, as scientists were messing around with these nanotubes, they noticed something interesting. When you arrange them in a certain way, they become really good at absorbing light.
Uh-huh. So that's when the light bulb went off. Someone
Yeah.
said, hey, we can make something really black with this.
Pretty much, there was this team of researchers at the National Physical Laboratory in the UK, and they started experimenting with different ways to grow and arrange these nanotubes to see just how much light they could absorb.
So it wasn't just a matter of sticking some nanotubes together and boom, you've got Vantablack.
Oh, no, it was way more complicated than that. I mean, they had to figure out how to create a material that absorbs almost all light, but is also durable enough to be useful. That took years of research and tons of experiments.
It's always amazing to me how much work goes on behind the scenes before we even hear about these scientific breakthroughs.
It's true.
So when did Vantablack finally make its debut?
The first version was unveiled back in 2014, and it kind of blew everyone's minds.
I bet it did.
It was officially the darkest material ever created.
That must have been a pretty big deal. I mean, it's like saying, hey, we've created a portable black hole.
Yeah, it was kind of like that people were fascinated by it.
I remember seeing those pictures online where they'd coat a crumpled piece of foil in Vantablack, and it would look perfectly smooth.
Right, even though it was all wrinkled up underneath.
It's so trippy to look at because your brain knows it should have texture, but it just looks like a flat black void.
It really messes with your perception.
So they came up with a catchy name, Vantablack. I've always wondered where that came from.
It actually stands for Vertically Aligned Nanotube Arrays Black.
Ah, so it describes both the structure and the appearance. Pretty clever.
Yeah, it's a fitting name.
But the story doesn't end there, right? I mean, science is all about pushing the boundaries even further.
Exactly. So, in the years since Vantablack first came out, scientists have been working to make it even better, more robust, more versatile, easier to apply to different surfaces.
So it's gone from a cool lab experiment to something with real-world potential.
Yeah, definitely.
It's really amazing how far we've come with this material. I mean, from those early experiments with carbon nanotubes to this ultra-black substance that's changing the way we think about light and darkness.
It's a testament to human ingenuity, for sure.
But let's be real here. Vantablack isn't perfect.
Yeah.
Right? We've talked
Yeah.
about the fragility and the cost.
Yeah.
Are there any other challenges scientists are up against?
Well, one of the big ones is applying it to larger, complex surfaces. It's not like you can just spray paint it on anything.
Right, because of those delicate nanotubes.
Exactly. So they're having to come up with new techniques like special spray coatings or even integrating Vantablack into other materials.
So instead of just coating something, you could actually create a material that has Vantablack embedded throughout its structure.
Precisely.
Wow. That opens up a whole new world of possibilities.
It does imagine 3D printing objects with Vantablack built right in.
That's wild. Okay, so we've covered a lot of ground here, from the origins of Vantablack to its potential applications. But before we jump into the future, I'm curious, are there any particularly memorable or unexpected uses of this stuff so far?
Oh, yeah. There's been some pretty cool stuff.
Like what?
Well, one that stands out is the Vantablack car.
A Vantablack car, you're kidding?
Nope. It was a concept car unveiled by BMW a few years back.
Wow. What did it look like?
It was pretty mind-blowing. Basically, the whole car was coated in Vantablack, so it looks like a 2D silhouette.
Seriously.
Yeah, all the curves and details just disappeared. It was like looking at a car-shaped hole in reality.
That must have turned heads wherever it went.
Oh yeah, it was definitely a showstopper.
It's crazy how this material can take something as familiar as a car and make it look completely alien.
That's the thing about Vantablack. It challenges our perceptions about how things should look, how light should behave. It's like it unlocks a whole new way of seeing the world.
It's definitely more than just a really, really dark black.
It is. It's a reminder that there's still so much out there to discover, especially when it comes to materials science.
That's a great point. So let's talk about the future of Vantablack. You mentioned earlier that scientists are always pushing the boundaries. What are some of the areas of research that have you really excited?
One area that I think has huge potential is developing more efficient and sustainable ways to produce Vantablack.
Right, because we can't ignore the environmental impact.
Exactly. The current production methods can be pretty energy intensive, and they rely on materials that might not be so readily available or sustainable in the long run.
So finding ways to create Vantablack without harming the planet is a top priority.
It is, and there's been some promising research in this area looking at using renewable energy sources and exploring alternative materials that might offer similar properties.
That's great to hear. It's important to remember that scientific progress should go hand in hand with environmental responsibility.
Absolutely. And beyond the sustainability aspect, there's a whole universe of potential applications for Vantablack that researchers are just starting to explore.
Like give us a glimpse into the future of this incredible material.
So we've talked about stealth tech and space exploration, but think bigger. Think like next level stuff like cloaking devices.
Cloaking devices, you mean like Star Trek stuff, making things actually invisible?
Yeah, pretty much. I mean, Vantablack's ability to manipulate light is so powerful that it could potentially be used to create optical camouflage that would make things virtually undetectable to the human eye.
So not just invisible to radar, but actually invisible to us.
Yeah.
That's insane. And what about those super efficient solar panels you mentioned?
Oh, yeah. Imagine coating solar panels with Vantablack. They would absorb almost every single photon of sunlight hitting them.
So no energy loss. That's amazing.
Exactly. It could revolutionize renewable energy as we know it.
Wow. So we could be using this super dark material to create a brighter future for the planet.
Yeah.
That's pretty cool.
It is, and there's more researchers are looking into using Vantablack to create ultra-sensitive light detectors.
Light detectors, what for?
For things like optical computing.
Optical computing. Okay. I'm going to need you to explain that one.
Sure. So basically, instead of using electrons to transmit information like in regular computers, optical computing uses light.
Light.
Yeah. And to do that effectively, you need super sensitive detectors that can pick up even the faintest light signals. And guess what?
Vantablack.
You got it.
Wow. It seems like the possibilities are endless with this stuff.
Pretty much.
Okay, so before we wrap up this deep dive, I have to ask, what are some of the big unanswered questions about Vantablack? What mysteries are scientists still trying to solve?
Well, one of the big ones is durability. We've talked about how fragile it can be, so finding ways to make it tougher, more resistant to damage, especially in harsh environments, that's a big challenge.
Yeah, if we want to use it for things like spacecraft or those super solar panels, it needs to be able to hold up under extreme conditions.
For sure. And then there's the issue of scalability right now. Producing large quantities of Vantablack is still really expensive and complicated.
So making it more affordable and easier to produce, that's key for wider adoption.
Absolutely.
Well, I think it's safe to say that our deep dive into Vantablack has been a journey into the depths of darkness and the potential of human ingenuity. It's incredible to think that something so dark could have such a bright future.
I agree.
It's a reminder that there's still so much out there waiting to be discovered, and that even in the absence of light, there can be amazing things to find.
Well said.
So all our listeners out there, keep exploring, keep questioning, and keep pushing the boundaries of what's possible. And if you ever find yourself staring into the darkness, remember, there might be something truly incredible hiding within it. Thanks for joining us on this deep dive into the fascinating world of Vantablack.